Hello everyone, we are from Group 1 CS2672A. We present the assessment 4 of MAT522. First of all, we will introduce ourselves. This group consists of 3 members, which is Muhammad Faris bin Muhammad Dani, second Muhammad Saiful Izan bin Shahril, and lastly Muhammad Azan Hilmi bin Khairul Amali. Next, we will proceed the assessment question. The question is, consider an RLC series circuit with a resistance of 10 ohms, an inductance of 0.5 Henry, a capacitance of 0.01 farad, and an applied voltage of 150 volts, assuming there is no initial current and initial charge is 1 coulomb.
Okay, now we will discuss about question A. The question A is, find the equation of the charge Qt on the capacitor at any time t. Do not solve for the arbitrary constants. Okay, to solve this question, first, we need to highlight the applied voltage, resistance, inductance, and capacitance from the equation. Okay, from the earlier question, we can get that the applied voltage, which is ET, equals to 150. The resistance equals to 10. The inductance L equals to 0.5, and the capacitance C equals to 0.01. Okay, the equation that given for this problem is LQ prime LQ double prime plus RQ prime plus Q over C equals to ET. Okay, now we will substitute the thing that we get earlier to this equation, which then we'll get 0.5 Q prime plus 10 Q prime plus Q over 0.01 equals to 150. After that, we'll simplify until we get 0.5 Q double prime plus 10 Q prime plus 100 Q equals to 150. Okay, then we will solve for QC. To solve QC, first we need to use the earlier equation that we get, then we will change its variable to n square. Okay, the result is 0.5 m square plus 10m plus 100 equal to 0. Then we will factorize this equation, then we will get the complex conjugate roots, which is m equals to negative 10 plus minus 10i. From this factor, we will get QCT equals to C1 E negative 10t cos 10t plus C2 E negative 10t sin 10t. After we get QC, now we will solve for QP. For solve QP, first we need to identify the ET, which is equal to 150. Since 150 is the whole number, then we will use Q. Then we will get QP equals to A. Then we will differentiate QP prime equals to 0, and then the QP double prime also equals to 0. After that, we will substitute this into the equation, into the earlier equation, which is 0.5 0 plus 10 0 plus 100 A equals to 150. Okay, then we will simplify the equation, then we will get 100 A equals to 150. Okay, then we will find A by 150 divided with 100. Then we get A equals to 1.5, and that's when QPT we get equal to 1.5. Okay, to solve the equation, first we need to construct this equation. QT equals to QC plus with QP. QC we will extract from earlier result and the Q and this QP. Then we will get QT equals to C1 E negative 10t cos 10t plus C2 E negative 10t sin 10t plus 1.5. Since the question did not want us to solve for arbitrary constant, then we will leave the answer just like this.
Okay, next we will move to the question 7b. Describe the type of the system. If we want to know the system, we need to check the R square minus 4L over C. From the problem, the R value is 10, the L value is 0.5, and the value of C is 0.01. Then we will substitute to the R square minus 4L over C, and we get negative 100. Since the value of R square minus 4L over C is equal to negative 100, which means less than 0, then the system is under the